Welcome back, folks. In today's class, I'll be continuing with the 2D problems and I'll take another 2D problem with some other directions. So let's say there is an object which is moving first of all along the northeast direction and then at an angle. Let me first of all display an angle also 30 degrees, and then same object moves somewhere along the northwest direction. So something like this. So this will be northwest direction. And I wanted to find the resultant displacement of this vector. So how I'm going to approach this question. Let's say this is 5 meters and this one is 10 meters again. And this second vector is at an angle of, I would call this one as, let's say this is at 45 degrees with respect to the x-axis. How I'm going to approach this kind of a question. So this is 10 meters, this is D2, this one I'll call it as D1. Again, so if you are given us some questions like this, then you first of all have to convert it into two different components or two different navigations and draw the vectors on those two navigation systems. So this will be equal, this is the first navigation system. So this is east, this is south, this is north, this is west. So first vector is 5 meters at an angle of 30 degrees, and the second vector D2 is 10 meters, which is somewhere in the northwest direction. So this is 10 meters at an angle of 45 degrees. This angle becomes 45 degrees. First thing first, I'll find the components of these two vectors. So first vector, I'll find d1x, which is equal to 5 cos of 30 degrees. Again, if you're confused how I write it as x component as 5 cos of 30, I can complete a right angle triangle here. Once we complete the right angle triangle, you can apply the trig ratios. This becomes the adjacent side, this becomes the opposite side. And if you're trying to find the adjacent side, you can write it as adjacent upon hypotenuse, which is equal to cosine of 30 degrees, and adjacent side is equal to hypotenuse times cosine of 30. Hypotenuse value is given to you, which is 5 meters, and 5 times cosine of 30 degrees. That's how I find out the x component or the adjacent side. Same way I can apply the trig ratio for the vertical side, d1y, which will be 5 sine of 30 degrees. You can apply the same approach to find out that. Show you down here. That is opposite upon hypotenuse, which is equal to sine of 30 degrees. Opposite side is what we are looking for, and hypotenuse is 5, and that goes on the other side. So this will be hypotenuse times sine of 30 degrees. Hypotenuse is 5 times sine of 30 degrees, and that's going to give me the opposite side for this. So if I do the calculation, this one again the same numbers which we've done in the previous class, this will come out to be 4.33, and this number will come out to be 2.5. Make sure your calculators are in degree modes, not in radian modes, otherwise you will get the wrong answer. Now if I look into this vector and try to find the component of this vector, so d2x, which is equal to, again, because I'm finding the x component, 10 cos of 30 degrees. You can complete a right angle triangle here also. And this will be 10 cos of 30. D2y value will be, oops, this is 45, not 30, 45 degrees. And D2y is 10 sine of 45 degrees. So sine 45 is 0.707. Again, I'll try and verify with the calculator also. Sine of 45, which will be 0.707. So 0.707, if I multiply, this will come out to be 7.07, and this value will come out to be 10 cos of 45, which is 0.707 again. So 10 times 0.707, which is 7.07 meters. This is also in meters. So we figured out both the components. This one is the cos component and this one is the sine component, d to y. Now we wanted to find, again, one thing which I haven't mentioned here. This one is in which direction? If I look into this diagram, this one is the y component is in the north direction and x component is in west direction. So this I can call it as west also, and this one will remain as north. Now let's find out the resultant. And this one, before even I find the resultant, I should name it as name the directions for the first one too. First one, x component was in the east direction. This was in the north direction. So this x component in the east direction, y component in the north direction. So let's find the resultant. So d net x. So I'll add up the x components. 4.33 east and d2x is 7.707 west plus 7.07 west. So 4.33, this is minus, this will become minus because it's in the west direction, minus 7.07. So if I do the calculations on my calculator, 7.07 minus 4.33, which is 2.42, 2.74 shall I write, 2.74 with the negative sign because this is a bigger value. And d net y value will be equal to, again, I'll write down the values in y direction, 2.5 and 7.707. So 2.5 north plus 7.07 north. Both are north, so both are positive numbers. I'll directly add them. So that will come out to be 7.07 plus 2.5, which is 9.57 meters. That is a positive number, so I'll write it as north direction. This was a negative number, so I can write it as 2.474 in west direction. I won't write it as negative 2.74 west. That will be wrong. Okay, either you write the direction or you write the symbol negative or positive in front of it. So now I wanted to find the resultant value. So for the resultant value, I'll again draw the navigation system and draw these vectors on the navigation system. This is in the north direction. So 9.57 in north direction. The other one is 2.74 in the west direction. This one is 2.74 west. And the resultant will be somewhere down here. That's the resultant. And I'm replacing this vector down here, which is 9.57, and completed the right angle triangle. Let me extend this vector down here. And I'll apply the Pythagorean theorem now to find the resultant or net value. So resultant is equal to 9.57 square plus 2.74 square, and this is square down here also. So our value will be square root of 9.57 square plus 2.74 square. So if I do the math on this one, that will be square root of 9.57 square plus 2.74 square, and that's gonna give me, the final value will come out to be 9.95. That's the resultant value. Now, if you might have noticed, I didn't take the negative sign down here. Even if you take the negative sign with this, it's not going to make any difference because square of negative is a positive number. Sorry. We've already shown the direction here, so we can finally, once we're going to get the number, it will be somewhere in the northwest direction. This is west, this is north. So we got the resultant here, and then I'll find the angle tangent theta, which is equal to opposite upon adjacent. So which is 9.57 divided by 2.74. Theta value will be equal to tangent inverse 9.57 divided by 2.74. So if I do the math, so that is second function tangent inverse 9.57 divided by 2.74, which is 74 degrees. So theta value will be 74 degrees. So final value will come out to be, if I compile the result, the displacement will be 9.95 meters at an angle of 74 degrees, approximately 74 degrees north of west, because I'm starting the angle from the west direction. This is the base while measuring the angle, moving towards the north, so north of west. So hopefully you understood the question, and I'll see you with another question. Meanwhile, if you like the lecture, think of subscribing it. Otherwise, I'll see you with other on the other side. Bye now.